You've probably heard of sloths before. Slow-moving, tree-dwelling creatures that spend most of their lives hanging upside down, munching on leaves, and taking life at their own relaxed pace. And if you're familiar with their distant relatives, the giant ground sloths of the Ice Age, you might picture massive, shaggy creatures lumbering across prehistoric landscapes. But what if I told you that millions of years ago, there was a sloth that didn't climb trees, or even live entirely on land? A sloth that swam, that spent so much time in the ocean it became something of an honorary marine mammal? Meet Thalassocnus, the sea sloth. Now, if you're imagining some kind of prehistoric otter-sloth hybrid, hold on a second. Thalassocnus wasn't exactly graceful, and it certainly didn't evolve into a sleek, dolphin-like shape like some land mammals that return to the sea, like whales. Instead, it was a slow, steadily adapting experiment in marine life, a sloth that dipped its toes into the water, and then, over the course of millions of years, just kept going. But how? Why? And what does a swimming sloth tell us about evolution and the weird, unexpected paths life can take? To understand how Thalassocnus ended up in the water, we have to go back to the Pacific coast of South America, between about 9 and 3 million years ago. At this time, the coastline of what is now Peru and Chile was home to a very different kind of ecosystem, one dominated by seagrass beds and shallow coastal waters full of life. And among that life, a strange, semi-aquatic sloth. The earliest species of Thalassocnus started out as shoreline grazers, hanging around the edges of the beach and wading into the water to feed on aquatic plants. But over time, something interesting happened. Each new species in the Thalassocnus lineage showed more and more adaptations for a marine lifestyle. It was a gradual but clear trend. These sloths weren't just hanging out in the water for a quick snack. They were evolving to live there. So what exactly changed? Well, at first, Thalassocnus was probably just wading into the shallows, much like a modern capybara or tapir. But as the species evolved over time, paleontologists started noticing some very whale-like changes in its skeleton. For starters, its bones got denser and heavier, a classic adaptation seen in other semi-aquatic animals, like hippos. This bone thickening, called pachyostosis, helped Thalassocnus stay submerged while feeding on seagrasses and algae. Think of it like natural ballast, making it easier to stay underwater and graze. Then, there were its claws. Early species of Thalassocnus had the classic, curved claws you'd expect from a sloth that still spent some time on land. But later species? Their claws started to straighten out, better suited for gripping the seafloor rather than climbing trees. And then there's the skull. Over time, its snout became longer, perfect for reaching and pulling up seagrasses, much like modern dugongs and manatees. And its jaw? It got stronger and more specialized for an herbivorous marine diet, suggesting that by the end of its evolutionary journey, Thalassocnus was spending most, if not all, of its time feeding in the water. It had, essentially, become a sea cow. But this raises a big question. Why? Why would a land animal, especially a sloth, take to the water? Why didn't it just stick to the forest like its relatives? Well, the answer likely has to do with competition. During this time, South America was home to some of the largest land herbivores of the era. Massive notungulates, giant ground sloths, and even early relatives of elephants. The forests and grasslands were crowded. But the coastal seagrass beds? Those were practically empty. At the time, South America didn't yet have fully marine herbivores like manatees or dugongs. And with little competition for food, Thalassocnus found itself with a perfect ecological opportunity. One that would push it further and further into the water over time. For millions of years, Thalassocnus thrived in its coastal niche. But then, something changed. Around 3 million years ago, the Isthmus of Panama formed, connecting North and South America for the first time in tens of millions of years. This triggered one of the most dramatic biogeographical shakeups in history, the Great American Biotic Interchange. Suddenly, new predators and competitors from the north were pouring into South America. And at the same time, something else was happening. Manatees and dugongs, which had been thriving in other parts of the world, finally arrived in South America. And unlike Thalassocnus, these were fully aquatic animals, better adapted to a life in the water. Between the arrival of better adapted marine mammals and changes to the coastal environment, Thalassocnus likely found itself struggling to keep up. And at some point, possibly around 3 million years ago, It vanished from the fossil record. The sea sloth experiment had ended. But imagine for a moment, what if Thalassocnus had survived? What if it had managed to keep evolving alongside modern sea cows? Could we have seen fully aquatic sloths gliding through the ocean like manatees? That makes you wonder just how different life on Earth could have been if just a few things had played out differently.